Hi, I'm Audrey, member of the Teen Advisory Board with Howard County Library System, and today I'm going to tell you about the power rule. The power rule is a tool used in calculus that allows you to find the derivative of a function. Today I'm going to show you what that means and how you can do it. So to start, let's try and figure out what the derivative of a function is. Here we have two examples. On the left, f of x. F of x is equal to x squared. On the right, we have the derivative of f of x, f prime of x. F prime of x is equal to 2x. We also have graphical representations of both functions. So if we're looking at f of x, it's a basic parabola, x squared. You've probably seen this function 100 times. Now, the derivative is going to tell us what the slope of f of x is at every single point. You're used to a function telling you the value. At x equals 0, the function equals 0. At x equals 1, the function equals 1. At x equals negative 2, the function equals 4. The derivative is going to give you the value of the slope of the tangent line. So if we zoom in as much as we can, we're going to imagine a line tangent to this graph. That means a line that touches the graph at just one single point. Let's say that point is at negative 2, 4. Now the slope of that tangent line is going to be the slope at that one singular point. We've got tangent lines here that are steep, and then they slowly get shallower or less and less steep. At the bottom we have a straight tangent line, then they're going to start moving up in the positive direction and getting steeper and steeper. Our derivative, f prime of x, is going to give you the value of that slope at every point. So that pattern we just described, large negative slopes that get less and less steep, a straight line at the bottom, where the slope would be equal to 0, and then tangent lines getting steeper and steeper in the positive direction. That's exactly what this graph is showing us right here. Large negative numbers getting smaller and smaller, 0, and then positive numbers getting bigger and bigger. So this graph here represents the slope of that graph over there. Now that we know what a derivative is, let's figure out how we can find it using just the function itself. So let's talk about what the power rule tells us. The power rule tells us that for any function f of x that equals x to the power of n, its derivative, f prime of x, will equal n times x to the power of n minus 1. Now, that might look a little bit confusing written out like that. So let's start with a couple of examples. Let's take a look at the function we were just working with before. F of x equals x squared. Now, if we compare this to the power rule, they look pretty similar. We can see that x is the base, and the exponent is equal to 2. So if we're trying to find the derivative, f prime of x, we can see it would be n, which is 2, times x, to the power of n minus 1. So this is going to be equal to 2x to the power of 1, and x to the power of 1 equals x. So it's going to equal 2x. And if we look at this, our derivative of x squared was 2x. So that's going to be correct. Now let's try a more challenging example. F of x equals x cubed plus 2x squared plus 1. For this example, it's important to note that derivatives can be distributed. For this particular function, its derivative, f prime of x, is equal to the derivative of x cubed plus the derivative of 2x squared plus 1. That means we can apply the power rule separately to each term within the equation, and this will make finding the derivative a lot more simple. So let's do that. Let's try and apply the power rule to each term within this equation. To start, x to the power of 3. If we're looking at our power rule, we're going to have to bring the exponent down, multiply it by x, and then lower the exponent by 1. So that's going to be 3x, and then 3 minus 1 is going to give us 2, 3x squared. Plus, let's take this next term, 2x squared. We're going to bring the exponent down and multiply x by it. So we'll get 2 times 2x, 2 times 2x, to the power of 2 minus 1. So that's going to be to the power of 1. And then we have this constant on the end here. We can't see any x that's attached to it, but we know that x to the power of 0 is equal to 1. So any constant is the same as that same constant, 1, multiplied by an invisible x to the power of 0, because that would be just like saying 1 times 1 is 1, which we know is true. So if we take that then, and we multiply the exponent 0 by by x, and then subtract the exponent by 1, we'll see that we'll get 0 times a term, and we know that's going to equal 0. So anytime you have a constant at the end of your function, when you take the derivative of that function, the constant will go away. It will always be something divided by 0. So when we simplify this, for the derivative of f of x, we're going to get 3x squared plus 4x. We're going to do one last example today. F of x is equal to 1 over x squared. Now, right off the bat, you're going to notice that this isn't in the same form as our power rule. It's not x to the power of something, it's 1 over x to the power of something. When finding the derivative, it's important to be able to rewrite the equation in whatever form is most valuable to you. In this case, we want to rewrite the equation as x to the power of something. And we can do that by making the exponent negative. So this is going to be the same as 1 times x to the power of negative 2 over 1. We just took the reciprocal of that function and made the exponent negative. 1 over x is equal to x to the negative 1 over 1. So 1 over x squared is going to be equal to x to the negative 2 over 1. That's a basic property of exponents. So now that we've got that, we have our equation in the form that we need. We can simplify it to x to the negative 2. Now we want to find the derivative of x to the negative 2. And we're just going to go back and apply our power rule. We're going to bring down the exponent and multiply x by it. And then we're going to subtract our exponent by 1. Negative 2 minus 1. That's going to give us an answer of negative 2x to the power of negative 3. And if you want, you can simplify it at the end to give you negative 2 over x to the power of 3. Now, the power rule is not going to work for every single equation. It can't give you the derivative for the natural log of x, or tangent x, or secant x, or any of the trig functions. In order to find the derivatives of those functions, you're going to need to do a little bit more complicated calculus and memorize some different identities. But the power rule is a very good building block to form your understanding of calculus and of derivatives. Thank you. I hope you enjoyed this video.